Good morning, Miss Rianne. Mom says you might need some support with this problem. Okay, so what they've done is they've given you a circle and they've drawn in some chords. And there's this theorem that the product of the means is equal to the product of the extremes, blah, 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 blah. So in order to prove that AE times EB is the same as CE times ED, what they really want you to do is prove that the two triangles, and I know I haven't drawn them in yet, inside the circle are similar. Because if we have similar triangle, the sides are in proportion. So what I'm going to do, and I'm going to do the statements and the reasons, a formal proof in a moment, but I just want to pull apart the picture. They give you this picture. What they want you to do is they want you to actually draw in some lines. I'm sure in class you call them auxiliary lines. Oh my God, my lines are so ugly. But what they want you to do is they want you to actually create two triangles within the circle. Then they want you to prove those triangles are similar. And once you know triangles are similar, the sides are in proportion, you cross multiply, and that little fact falls apart. So the key to this, if you don't draw in and understand they want you to look at these two triangles, you don't have a shot. So I'm going to do it formally in a moment, but I just want to pull the picture apart. As soon as you draw in your triangles, hopefully you look here and you go, oh, angle CEB, that angle is congruent to AED because those angles are vertical. So you're like, all right, good. I got a couple of congruent angles. If I can do angle, angle, then I know I have similar triangles. And the other angles within these triangles that will be congruent are these angles right here. Angle C is actually congruent to angle A. If you look at arc BD, if we knew arc BD, this angle here, angle C, right? If you look at the interior angle from that arc, will be half that measure of that arc. And if you look at this arc BD, there's another inscribed angle here, this crazy little angle A, and that too, because they intersect that same arc BD, that measure will be half the measure of arc BD. And those two angles are congruent. So then you're going to have angle, angle, and we've proved the triangles are similar. That's the key to this problem. But let's do it formally, because that's what your teacher will want. But whenever I'm having to put together a proof, I first really focus on the picture and pull apart the picture, and then I back it up with formal proofs. So you got your statement, you got your reason. So first of all, if two chords intersect in a circle, the product of the lengths of the segments of one chord is equal to the products of the lengths of the segments of the other chord. I was looking for the given. Okay, here's our given. So you're given circle O and chords A, B, and C, D. And your reason for that would be given. And then when I pulled apart the picture, the next thing I did was draw in these lines. So, two lines CB and AD are drawn in. Drawn. And our reason for that is auxiliary lines can be drawn. Auxiliary, I'm probably spelling it wrong, lines can be drawn. Okay? Once you have those lines drawn, the next thing I did in the picture was I said, oh, angle CEB was congruent to angle AED. And why are those congruent? The reason is vertical angles are congruent, okay? Little bow tie angles, vertical angles are congruent. The next thing I said was angle C. You can just call it C if you want, or if you want, you can call it BCE, is congruent to angle BAD, right? Maybe I'll even make that a D. Doesn't matter. You could even say angle C is congruent to angle A. They'll know what angle you mean. But I'm naming it BCD, congruent to BAD. And the reason those are congruent, inscribed angles that intersect the same arc are congruent. Inscribed angles that intersect the same arc are congruent. And that's what we talked about. We talked about the fact that BD is the arc. You have this inscribed angle. The measure of C will be half that arc. And if you look at BD again, A is also an inscribed angle for that. So that measures half BD. So both of those measures will therefore match. Alrighty, Roo. So now we have just proved triangle BCE is congruent to triangle. Oh, not congruent. Oh my God, are you kidding me? You can tell it's not even 5 a.m. yet. BCE is similar to triangle EAD. And that tells us that the reason being would be angle criteria is met. So your teacher will just let you put angle. Oh my gosh, I'll probably have to go to another screen. But now that we know they're similar, those triangles are similar. Number 6, we know the sides are in proportion. So we know AE, that side, AE, here I want to get down, I'm going to squeeze 7 in, then I'm going to back into the sides I want. You're trying to prove AE, oh, I'm at the bottom of my screen, so it's not going to write nicely. Are you kidding me? AE times, EB, I'm going to back into the one before it, sometimes I have to do this, is equal to CE times ED, and 7 product of means is equal to the product of the extremes. Okay, so now that I have that, I can set up AE over AE, maybe to CE. Let's say CE. CE is congruent to, or equal. Equal will be fine there, whatevs. And then on the other side, I'm doing AE to CE. AE is proportional to CE. And then the other one we have on the little triangle is ED. I'm having to use this here. So ED, I'm just doing little triangle to the bigger triangle. So ED, and then this is EB. I had to back into it based on this bottom part to see what size they wanted in proportion. So this is little triangle to big triangle. AE is to CE as ED is to BE. And then that is sides of similar triangles are in proportion. Okay. And then you just cross multiply. AE times EB is congruent to CE times ED. That's called the product of the means equal to the product of the extremes. I hope that helped. This was actually from August, I don't know, was it 2016, Regents? If you ever need, I mean, my winning personality, I'd want to watch a video that I make, but if you know the date and the number, you just on YouTube check out Geometry Regents August 2016 number 35. You'll have videos come up all over the place, I'm sure. My favorite, if you're not into videos, JMAP, that school district. If you Google JMAP August 2016 Common Core Geometry Regents, you'll get a PDF answer key. That school district always puts them out, and I always like the explanations they do for kids. So if you just want to read over an explanation, they always have a nice one. Also, if you just Google August 2016 Geometry Regents, New York State puts up what they call like sample answers, and you can always scroll through the sample answers. I can show you how to find that if you need. But really, you probably want my winning personality, Rianne. All right. Good luck. I hope that helps.